The day the FBI came to the house, the sun was bright and the sky was a brilliant, cloudless blue. The air on the quiet suburban street smelled of freshly cut grass and warm asphalt. Neighbors were out walking their dogs, their gentle chatter mixing with the distant whir of a lawnmower. Children rode their bicycles in lazy circles on the sidewalk, their laughter echoing in the calm afternoon. It was an ordinary day, filled with the simple, predictable rhythms of life. But inside one small, unassuming garage, something extraordinary was happening. A 12-year-old girl named Maya was building a machine, a device born from curiosity, and a love for the fundamental forces that shape our universe. Maya was a child captivated by science. She did not just read books, she absorbed them: magnets, light, the tiny electric motors that made her toys move. She was an explorer of the principles that governed her world. Her bedroom was a small universe of tools and components: wires, batteries, and shelves lined with jars of screws, resistors, and capacitors. Her notebook brimmed with intricate drawings and careful notes. She called her project her fusion lab. She knew real fusion-powered stars with immense heat and pressure far beyond her garage. Hers was a playful imitation, but she loved the name. On a small table, 2 strong speaker magnets, a glass jar, and a clear plastic tube. A coil of copper wire, salvaged from a discarded radio. Power came from a simple plastic battery pack. She glued a tiny blue LED to a metal ring, hung it over a minute pile of a special fine powder from a vintage kit, labeled for adults only. Next morning, as Maya finished her cereal and ideas, the doorbell rang. The men were polite, speaking in measured tones. They introduced themselves as agents from the FBI. One flashed a badge. Maya's mother felt a jolt of nerves but stayed calm. They asked to come inside to ask a few routine questions. Maya felt her stomach flutter. Her world of experiments met their world of procedure. They were professional, but not intimidating. They asked about the garage, who used it, and the tools inside. They asked about recent projects. Mom explained Maya built small, harmless gadgets and showed neat diagrams and notes. Pens moved efficiently. They asked where the powders came from. Mom pointed to standard kit jars on a shelf. They said they only wanted to ensure materials were safe and handled correctly. Proud and scared, Maya led them to the garage. She put on her safety goggles. They were careful not to disturb anything. They observed the wires, the ring, the now dark blue LED. The garage felt like an exhibit. It was a strange morning. He didn't touch a thing. He asked Maya to explain the device: the coil, the battery, the light. He asked if she tested outdoors, or if it ever produced more than light. Who helped buy parts? How did she store powders and components? She answered honestly. They explained, some hobby chemicals and custom battery circuits can be dangerous if misused. News from a federal agency does not always arrive quickly. 2 days of quiet uncertainty, pride, and profound worry. Maya kept busy and avoided the blue star. She fixed a neighbor's toy and soldered a loose wire under supervision. She painted a model rocket, steady hands placing decals. She drew constellations and planetary orbits. Her curiosity turned upward. She asked Mr. Paul, "How do stars really make light?" He smiled. "Set a simple demonstration. Gravity squeezes hydrogen until it fuses into helium, releasing light and heat." He made stellar nucleosynthesis feel close. Science is collaborative and multi-generational, built with safety and shared knowledge. 2 days later, the phone rang. The news was good. The powder was perfectly safe. A phosphorescent zinc sulfide, common in glow toys and kits, designed to absorb light and re-emit it slowly. Not explosive, not radioactive, not hazardous in the feared ways. But the warning labels exist for a reason. Some combinations can be dangerous. Maya had done many things right. There was still a vulnerability. He asked her to avoid any unknown or unlabeled powders and to show every new plan to an adult before starting. Maya readily agreed. The atmosphere lifted. Uncertainty gave way to clarity and purpose. The rules would be rewritten, not to restrict creativity, but to protect it. Word of the FBI's visit spread, not as gossip, but as a curious murmur. Surprise gave way to pride. They saw a brave, curious young scientist. Maya's mother resolved to be more involved. Together they set clear rules and a formal logbook: date, materials, outcome, pre-approved parts and suppliers. No new experiment without a safety briefing. The story sparked community talks about nurturing curiosity safely. The library invited Maya to present. Nervous, then determined. She showed her device and spoke plainly about her goal, her love for science, and learning from mistakes. was infectious. A teacher proposed a district-wide makers club with supervision and proper gear. The idea gained traction fast. What was once frightening became a catalyst for safe, hands-on education. In the aftermath, Maya kept building with greater focus and discipline. She kept the blue LED, a memento of her most famous project. She powered it with small solar cells and stable rechargeable circuits. Her notebook grew precise, clear diagrams and detailed safety checks. The visit became a gentle local legend, a story told to teach. Be curious, bold, creative, careful, and ask for help. Rules didn't stifle the fun, they enhanced it. Maya's small experiment lit a spark across town. She often looked back at that photo, a tiny captured star, and the line in her notebook, Blue Star Works.